Well, hello, everybody. Good afternoon, good morning, good evening, good middle of the night, wherever it is that you are. My name is Buck Woody. I'm an applied data scientist here at Microsoft, and that means I take data science and I have to actually implement it somewhere. So I work with a lot of our clients and things. So my background, I'm very old. I think you can kind of see that automatically there. So I started back in the mainframe days. But I've been in data my entire career. The military for a while, worked at NASA for a little while, and around the world in different organizations. And now I've been here 15 years at Microsoft. Started on the SQL Server team, and then went out and worked in the field with SQL Server, working on customer projects. And then sort of over time, I found out we had this code project, something called Red Dog. And I said, I want to be part of that. I lived up in Seattle at the time. And I jumped on that, and that became Microsoft Azure. So I was on the team that helped build some of that product. And of course, that's grown just a little since the days we did that many years ago. And one of the first places I dived into on that was the data area. So I've been in data ever since. And I've worked in everything from unstructured data, just files. We used to link them with COBOL and so on, all the way up through the incredible variety that we have to process data. So what I thought we'd talk about a little bit today, this borders on the bigger concept called sort of the modern data architecture. So this is companies, probably had lots of different engines and data systems within their company, maybe some on the cloud, maybe they use some services, Microsoft CRM or Salesforce or something like that, and they're pulling data from lots of different places, and they may be doing it in a less structured way than they'd like. And so a lot of companies are contacting us, actually quite a few lately, saying, can you help us understand sort of what the modern way of doing this is? And it's kind of interesting because lots of companies, large companies, think that everybody else is ahead of them. And so they're like, well, we haven't upgraded in a very long time. We haven't looked at this stuff. We're trying to get our job done every day and so on. So I counsel them that, hey, everybody's in the same boat. So one place to start is with a data lake. And you're probably already doing a data lake. You just either don't call it that, or it's not done in sort of a formal way. So I thought what we might do is spend a few minutes today. We'll go fairly quickly. You'll get the deck, you'll get the materials, and at the end I'll give you a full workshop. So don't worry about getting the materials, and the materials have links in the notes section, so you can pull those down and so on. Ron will get all those to you. But let's talk about what a data lake is, and then sort of go from there. So I'm assuming that you are a data professional. Maybe you're not, but I'm assuming you're a data professional. I'm kind of rearranging my screen here so I can see my slide deck well. So let me fiddle with this thing for just a moment. There we go. Now we've got it to where I can see what's happening. All right, there we go. Perfect. I use so many broadcasting tools that sometimes I have to remember which one am I on now? Am I on Zoom? Am I on what am I on? So here we are. The data lake architecture. So the easiest way to talk about what a data lake is probably to talk about what it isn't. Most of you are probably familiar already with sort of business intelligence, right? So we've got data storage that we do either in a relational way, using a relational database management system like Oracle or SQL Server, Postgres, something like that. And then we've got non-structured data, which is probably just sitting in a data store somewhere, file system, something like that. So we're all probably familiar with business intelligence. But a data lake is just like a business intelligence system, except where it isn't. And it differs in these ways: value, architecture, operations, and management. So let's talk a little bit about what a BI system is, business intelligence system is. And again, you're probably familiar with this already. But let's just talk about some of the ways you do that. Now, we're going to talk sort of product and vendor non-specific for a few moments, and then I'll show you some Microsoft examples. There are others, but you'll be able to learn sort of both from this. Here we go. So the first thing in business intelligence is those are usually pre-computed or modeled data sets. In other words, what we do is we set up a fact table, which is a bunch of numbers. You have dimension tables that point to those facts. and it's a fairly denormalized but relational system. There's a key that puts everything back together. Now, because it's relational, you get into something called the CAP theorem. I'm not going to go into CAP theorem today. We'll do that on another, when I teach college, and maybe we'll cover it when we teach college. CAP theorem is kind of interesting. But the idea there is you have to have a scale-up architecture. CAP theorem has to do with the ability to transmit things at the speed of light, and at some point you can't lock the data correctly. And so you have to keep, for a relational system anyway, you're going to have to scale up on a single system. What do we mean by scale up? We mean more CPU, memory, disk, and network, right? Those big four. The next thing is they're usually tightly coupled. Like I need to import some data, I need to do some stuff with it, and so on. So my storage and my processing are usually together. In fact, they're usually integrated to where the storage engine that stores things and lays things down is coupled with the code that processes it, queries it, updates it, and so on. The next thing we have is we have to have a schema to do that. You're going to need to say it goes in here. This is a declarative referential integrity, DRI. It means I will say this is a field, it can be this long, it can have this kind of data, and if it doesn't, I won't put it in there. That's a great guarantee. It's very safe, but I have to define that sort of ahead of time. So I got to think about it when I do it. The next thing it has is a 3-click interface. So what do I mean by that? Well, 0 clicks means that I get a report that just gets emailed to me or it shows up on my phone. 1 click is maybe I go look at a report. 2 click is I look at a report, but I can change some things. And 3 click means I can actually get a palette and I can drag things and I can build my own reports, like Power BI or something like that. And then they use an ETL process, extract, transform, and load. And what that means is you go get the source data from wherever it lives, and then you transform it so that it fits that schema. You have to fit it into that schema somehow, and then you load that data in, and now it's available for query. And then we have this sort of a pull load bias. We usually go get data. We don't usually have it dropped off somewhere. So this is a business intelligence system, long explanation. Just want to show you the difference between what a data lake has involved. Well, a data lake looks a little different because it has raw data sets. What does that mean? It means we don't change it in any way. When the data lands, let's say from the Internet of Things, like the smartwatches and phones and health meters and so on, they're dumping data as they get it, and as they store it, they dump it raw into this place. We're going to talk about the place in just a minute. The next thing is it's a scale-out architecture. So you've got storage separated from compute. And you may then do distributed computing methodologies to put the computation back over the data when you need to do that. So this scale-out architecture allows us to go much larger. We get up into the petabyte, exabyte, zottabyte range, those sorts of things. They're also loosely coupled, meaning the storage could be one thing, the processing could be 4 or 5 other things. The fact that you've stored data in a certain way with a certain kind of computation or engine doesn't mean you're going to use the same kind of code, maybe not even from the same vendor, to look at it. And we'll see an example of this in a moment. Next is it's a mixed. We may have some structured data, and we do the typical schema on write, but we may do some schema on read. Like I'm going to go grab a bunch of data like I used to do in COBOL, read it in, and then I'll say, well, from here to here, that's the first name, and from here to here, that's the second name, and so on. I'll apply that structure as I feel like it in my code. This is called, by the way, when you're writing the data, called programmatic referential integrity. It means the database doesn't define how the data lays down. It means that the program has to define that. It's a little scarier, and it's why we invented DRI to begin with, but that's yet another college class we'll do later. We have programmatic access this time. Rather than a single kind of language that we'll use to query these things, we use lots of languages. Usually there's an API, an application programming interface, over the top of that. And then we have, instead of just ETL, we have pipelines. And pipelines are usually around like events, things that happen, data sources and sinks, places where data goes from and to, and then usually the pipeline is the organization of all those little primitives that goes along. Data comes in, it does this, it does that. You can think of this loosely like SQL Server integration services. It's kind of a pipeline engine, but Azure Data Factory would be more along the lines of a traditional pipeline system. And we usually have a push load bias. In other words, we're going to let those IoT systems dump the data directly into the data lake. It's going to look like storage, or it's going to look like a sink, or it's going to look like a stream, or it's going to look like whatever to the source device so that we can load data very quickly and in massive parallel. Well, how do we get value out of this system? Well, the way we do it is by building these sort of layers. I want to start introducing this. We don't have a lot of time to spend on this. I've got a full day course I teach on this kind of thing, but we'll just stick with this for now. The first thing, these are sort of the principles of getting good data out, is that we need some really strong data foundations here. And then off of that, what we want to do is figure out what we want to measure. We often call this scorecards. And these are your traditional OKRs or KPIs, those kind of things that you might have heard about. And then we need analytics. We do still need intelligence. Analytics being sort of historical and not necessarily predictive in nature. But then we also want those predictive and classification natured events to happen on that same data. So we want machine learning and AI. So as you can see here, we've got quite a few things we want to show up inside from a single system. And that's kind of how you derive value from it. Well, if you think about it, there's AI, there's analytics, there's scorecards, and then there's secure data foundations. Those are all really big subsystems. And this idea of a data lake begins to put them together. So now let's talk about how we design a data lake. All right. So we need to think about things for storage, compute, and your data paths. Those are your three big things to keep in mind. And along that, you're going to start thinking about a couple of big terms. There's more, and this is where it gets a little religious in nature. Certain vendors have decided to rename things or use different terminology, and that's fine. I'm staying with the sort of the industry standard here, and then how everybody implements it, including us, including Microsoft, may get termed a little differently. But I want to describe these things to you. And the first thing you need to know about, the first sort of big concept, is something called a zone. So when the data starts, it's provenance. What in the world does that mean? Data provenance is a term we borrowed from the French, provenir, and it says to come from, right? That's what that really means. And it's the chronology, the time stamp of ownership, the custody, the relationship, and so on. You know, it was traditionally used in works of art. So if you had a painting from Michelangelo, that would have a provenance attached to it, right? So we're going to borrow that term. It's used in archaeology and other scientific fields as well. All right, so we think about these zones. So think about this as it marches through. So zone number one is something we call the transient zone. And the transient zone is sort of our source of our data ingestion. This is going to be used by IT and data pros, and it's impermanent, meaning that it will come and go. We may not keep things in here. And if you're familiar with Spark, if you've ever used Spark, as Spark reads RDDs, resilient distributed data sets, up into memory, one of the things that kind of freaks DBAs out is that Spark will make a copy. So it gets, let's say, for instance, you wanted to do a particular select statement in SQL. It would read the data, and then it would, give you back whatever data you asked for. Because Spark is so large, it would actually read all the data, then make a copy of it and put a where clause on it, and then make a copy of that for your next where, and so on. All of these different things would be layered, and there's copies of them. There's tons of storage just getting littered all over the place, so it can literally go back and forth as it needs to, and it can also work in parallel. That's sort of the key. And so the RDDs in a data lake would land here if you're using Spark. So it's a transient zone. Think of the main ingestion, very raw, no changes, and the only people touching this is IT. That's literally the only people touching this. Next, we have something called the raw zone. So this data here, it's going to be homogenized so that numbers are numbers and letters are letters, kind of at that level, really primitive level, but it's not transformed yet past that. It's just going to get it kind of in one place is all. And here, who's taking care of that are sort of the extract, transform, and load professionals, your data professionals, and data scientists. So a data scientist, we're very careful to make the data as raw as we can get it, because the second you touch it, you've affected it. If you change its length, if you change it from M to male and F to female and B to blue and so on, that means something to us. That breaks everything. So we don't want you to change it yet. We'll take care of that down the road in our Python or our code. All right, so that's the raw zone. And that's a little more permanent, by the way. The next is what we call the trusted zone. And by the way, I'll come to this, but the pipeline is what is moving all this data through. That's what's handling all this. We'll talk about how that works in a minute. The trusted data is sort of governed. In other words, somebody's looking after it. It's quality controlled, so there's no duplicates, things like that. And here what you do is RBAC or role-based access control. Like, oh, that's a finance person. They're allowed to see these slices of data. So we go from sort of a pot of data anyone can look at, anyone with permissions, down to a specific set of permissions by sort of role. Now here we begin our transformations, and this trusted zone is the single source of truth for the company or the organization. You would think about here the sort of your fact and dimension tables. That's where this would go, and your really strong ETL is sort of starting here. And that's whether that's structured data or unstructured data. It all goes to the same. All right, here we go. We've got a refined zone here. And now what we've done is we've created our data marts. You know how you want certain lines of business want things, a pot of data they get to look at for that 3-click report thing as a data source? That's what this is. And finally, we have a sandbox. What's a sandbox? A sandbox is an area where you can do whatever you want. You can suck out some data, drop it in here, play around with it to see if you like it, and then maybe put it back in the pipeline to say, okay, now I know what transforms I want. You don't want to be doing that in your trusted zone or your refined zone. You want to do it in a place where you can just try things out, like a proof of concept or something like that. Okay, so zones are our first thing we need to understand. Second thing we need to understand, and the tasks you're going to need to learn, is the governance. And this gets a little interesting here. The first is data tagging, and data tagging is exactly what it sounds like. You take a datum, like first name, and you can tag it and give it any number of tags. Think of this like you're searching it with a web search or something is the tagging. Next thing you want to do is metadata management. When did that get laid down? Who has access to it? When was it last updated? Where did it come from? What's the phone number of the person that owns that data? And so on. This is all metadata around the data. And then next we need our security gates and the policies we have for that. That's something you need to think about. You got to be very careful because people can put things together. I once worked in the military for a while, and we had to be extraordinarily careful because if you put together certain orders from certain companies, you could tell what we were building, and we don't want the enemy to know that. So we had to be careful about that sort of data security. Next, you need an audit trail. Who did that? And when did they do it? That's what you need to know. Did they put something in? Did they change something? Did they take something out? You need to know that. It's a full audit trail. And then you need to be able to see it. How do you find what's there? You need a search tool to be able to look at your data. And finally, you need to record that lineage, when it was changed, what it was before, and all that's encapsulated in provenance. Wow, this is a lot. So what's involved? Well, there's several options that you have to do something like this. We have a few. Microsoft has a few, and there are others. Inside Azure, if you're going to go cloud first, and by the way, at Microsoft, we do not talk about either or, like cloud or on-prem. We like to talk more about and. So you can do it on the cloud and you can do it on premises, and they can talk to each other. So the examples I'll show you can reach sort of back and forth. In Azure, we have the Azure Data Lake. We have Azure Synapse, HD Insight. Okay, let me pop over. Just going to pop over to some, here we go. I think I've got these up. Yeah, I do. So inside Azure Data Lake, just wanted to show you this graphic here. This is, and I'll give you these links. They're in the deck. All right. So here we see the data lake, and really it's two pieces: compute and storage. Right. You see down here we have a full store that will store unstructured, semi, and fully structured data, and it's also accessible by Web HDFS. So HDFS is the Hadoop distributed file system, and Web HDFS is an HTTP protocol over the top of that kind of access. Up at the top, we have full sets of analysis. If you want to do regular structured data, you can use USQL or Universal SQL. You also have R and Python as well. We also have HD Insight clusters and so on you can use on that, and Spark clusters you can use. Then you can cluster all of these together to do some fairly large things. So that's Data Lake. So it's ready to go, and we still need some parts here, and I'll show you those in just a moment. And the next thing is Azure Synapse Analytics. This is our Azure Data Warehouse from before, but we've added Spark into it. So you now have all the data warehouse stuff you had, and now you have Spark, and it's able to use all kinds of storage. You can go out here. Once again, there's a full set of documentation I'll point you to in just a moment. We also have Azure HD Insight, and HD Insight is our Hadoop distribution as a service. Hey, I need a cluster of Hadoop. Okay, I'm done, turn it off. You can do that, which is way easier than installing it locally. Sometimes you have to install it locally, so we'll talk about on-premises more in just a minute. Now, those are like some of the major components you can use in sort of this grouping of a data lake. But you need a way to move it around, so we do have the Azure Data Factory. Let me come up into the Azure Data Factory here. Yeah, the Azure Data Factory has these activities, Hive, stored procedures, all kinds of other things, copy activities. They're just things you do, and you do those to a data set. So you say, hey, I've got some data over in, I don't know, my Oracle database on premises, and I've got some data in a storage in AWS, and I want to bring those together, and you bundle all that together into something called a pipeline, which has schedules and steps and logging and error shooting and all that kind of stuff. And it'll show you kind of, you can come from just an absolute ton of stuff, DB2, Redshift, Google BigQuery, Informix, Access, everybody. Of course, we're going to use Access, right, for big data, SAP HANA, and so on. So you have all these available to you. Now, once you're done, remember we had that curation and metadata and tagging and all that. You actually have that in Azure Data Catalog. So Azure Data Catalog can suck in data from various sources, doesn't store the data, it stores the metadata, and you can query against it, and you can put tags on it, and you can give it permissions. These people can, and it allows you to let your folks discover their data much quicker. Okay, let's get back to slide world, unfortunately, and talk about, I don't like doing slides, but hey, they're a way to get some information across. So you can, of course, use SQL Server. SQL Server can go up into the very high ranges of data all by itself with a scale-up architecture. So that's definitely still included. SQL Server runs on premises, in the cloud, and lots of places in between. We have a new feature inside SQL Server 2019 called the Big Data Clusters, and I'll dive into that and more in just a minute here. In fact, let's do that now. Basically what Big Data Clusters is, it runs in Kubernetes. So Kubernetes is a way to corral a bunch of containers, if you will. And containers are sort of processes in memory that are shielded from each other that don't need as much weight as a virtual machine. So if you get a lot of these containers, you need a way to kind of bound them and give them storage and give them security and keep them running and so on. That's what Kubernetes does. And there's a few versions of Kubernetes. We have one in Azure. Google's got one. Amazon's got one. Red Hat has one. We'll run on all that. So all you're about to see will run on premises. You can install it locally, right on your laptop or your big computer at work, or you can install it in the cloud. So the Kubernetes gives us sort of a full control service. And then what we do is we lay down a little piece of software which has got all kind of monitoring and management stuff, because we're about to bring open source and SQL together. So the first thing we do is we lay down SQL Server in something called a master instance, and then we have a data pool, which is a scaled out data warehouse inside this thing that's running on SQL Server. You only have to talk to SQL Server, and it can talk both to relational data and out to the data pool, which is large relational data. And that's called HTAP. You're familiar with OLAP and OLTP, online transaction processing. HTAP is hybrid transaction analytic processing. It's OLAP and OLTP together. It's just SQL, just T-SQL. Now what we can do is we can actually have the SQL Server talk to other kinds of data, Oracle, Teradata, MongoDB, HDFS, as if it's in SQL. It's really kind of spooky to see that work. Now, what if you need to scale out the compute of all that, though? We actually have another set of servers that's involved. Again, you don't have to talk to the ones inside the boxes. You just talk to SQL Server. But we also throw in Spark into this mix so that you can actually talk to, and it can mount HDFSs in itself or even somewhere else, like Amazon and so on. And then we give you a place to throw applications like a Python Flask application if you've written machine learning code. Now, from your standpoint, you talk to SQL Server. It handles all of the scale. But you can also talk to Spark using Spark things. The interesting thing is the stuff you do in Spark is available to the SQL Server instance as if it's a table, which is really interesting to play around with. And then, of course, if you've written an application, you can hit it. So your entry points are very, very simple in the SQL Server big data clusters. Well, let's talk about using this in a data lake scenario. We talked about a little bit about what a data lake was and what it needs. So there's our big data cluster, and I've just sort of minimized the compute pool because it's not germane to what we're about to talk about, but it's still there. Now remember, we need stuff to run. We need a way to ingest data. We need a way to do lineage and provenance. We need a way to do tagging. We need a way to do metadata management. We need a way to do security and audits. And we need to discover all this data. So you have a few options. One is you can purchase something that does these things, that talks to SQL Server and Spark, let's say, or HDFS. They make packages that do these things. What we find really, though, is people are sort of using a mixture of the native tools of SQL Server and Apache, the Apache infrastructure and Spark. So things like SQL Server has, of course, backup and restore, import-export wizards, BCP, anybody, the bulk copy program. You can also use the very powerful SQL Server integration services to act as sort of the ingestion, the lineage, the security and audits, and so on. It provides a very rich infrastructure for that. And then we have within SQL Server something called the master data services. So you can get some of that tagging and that discovery of data that you've been looking for. But Spark also has very similar programs that will work with large-scale data. So we find people mix these. Like a native Spark read. Like Spark, you can actually just say, open this particular frame, and it will go out and read the web, or read Oracle, or read SQL, or whatever you need to do. These are using something called Spark connectors. And then Kafka is another very common open source product that you'll see used. HDFS tiering we have built into SQL Server, so we can mount our HDFS, we can mount another HDFS into it, so you read from there and it will take care of the read over there. You can use Uzi, Scoop, if you've ever heard of the SQOOP, which will ingest SQL data very, very quickly. And then there's a thing called DistCP, DIST-CP. It's a hard one to say, DistCP. But anyway, DistCP is distributed copy program. So it uses the power of Spark's distribution to pull down data. Wow, so much to think about here. I'm sure there's something that you'd like to know more about here to find out more. So I'm going to give you a link here. All of these things, the SQL stuff, the AI stuff, the big data cluster stuff, there's a workshop you can take to learn a little bit more about this to go from there. So what I'm going to do, I'm going to leave this up just for a second. So everybody can type this down. We got to make sure we stay on our time. I want to be really polite to the next speaker there, Ron. So I'm going to leave that for a moment. Once it's done, I'll stop sharing because I can't see comments and things. And what I'm going to do is I'm going to stop sharing now because I want to see the comments that you guys have. Let me see what we got.
Hey, Buck, if you go to the Q&A, Doug had a question about SQL Server.
Yes, sir.
Or SQL Linux. And
yeah, okay. Says SQL Linux runs on WSL2 on top of Windows Hypervisor with all the file locking. How SQL can on container handle file locking or is a front end to data lake only? Great question, Doug. So what we've done, this is kind of interesting for SQL on Linux. We thought about rewriting SQL to work in Linux. But we're not going to keep two code bases. That's what some other vendors do. It's really hard. Things begin to drift and change. So we said we're not going to do that. We thought about emulating Windows inside of Linux. And I've been a Linux guy for a very long time. And it's just bad news. You just don't want to do that. So it's so slow. It's so awful. So what we did was we took a pair of digital scissors and we found everywhere that SQL Server talks to the kernel. And we trimmed that away, and quick like a bunny, we replaced it with a layer we call the PAL, the Platform Abstraction Layer. Now SQL Server talks to the PAL. And when the PAL says, oh, you want to access memory, you want to do a thunk, or you want to do a whatever, you want to do a CPU call, you want to do a network call, you talk to me, I know how to talk to Linux. So SQL Server thinks it's in Windows. So all the locking and everything is just automatically handled. It's the same code base. Nothing changes. In fact, you can back up a database on Windows and restore it with no changes into Linux. You can do it the other way as well. And because the containers are a Linux kernel underneath, that's how that sort of works. Okay. All right. Let me see if there's other stuff in here just in the comments, big guy. Here we go. Why do SQL Server on Linux though? I mean Windows SQL Server. It's not Windows SQL Server, it's SQL Server, and it happens to run in Linux. And it's because of these containers, because we wanted this distribution. Long live the mainframe. The guitar is in fact an Ibanez. It's a G10. It's a little guy. Lets me practice when I should be listening during meetings. It's a little shorty is what that one does. Let's see. Reference architecture from Bala. Okay, and I think that's all the comments we have. You're welcome, Doug. No worries, man.